Great, thank you, Daniel. So my name is Barrett, and I'm from the University of Manitoba. And today I'm going to produce some work that I did at Autodesk in Toronto, where I was working with Tovi, Fraser, Justin, and George. So we all know that wearable devices are becoming much more common, and they're increasing in availability. And as people start to wear these every day in everyday usage, it's inevitable that these are going to, computing activity is going to start to encroach on everyday social and workplace interactions and encounters with other people. However, as these devices become smaller and more private, this also introduces the problem that the people who are around the device users are going to have a very difficult time understanding the activity that's happening on those devices. So previous approaches to this problem have tended to focus on trying to foster social acceptability by keeping the interactions hidden. For example, some prior work has suggested that subtle hand gestures can be used or detected by some sensors worn on shoes, or that some face gestures can be used in a very subtle way to keep others to prevent unwanted attention from other bystanders. And more recently, some of my colleagues looked at some additional ways to support subtle and even deceptive interaction, for instance, by hiding a display in a coffee cup or using the surface of a book as an input device. So as an alternative to subtlety, we propose candid interaction. So with candid interaction, the idea is that device users will voluntarily provide some awareness to others about how they're using your devices. So for example, imagine you're at a meeting and somebody pulls out their BlackBerry and starts typing away, and of course this has never happened to anybody before, right? But just imagine that this is the case, and you're wondering, what the heck is that person doing? They're checking their email. How rude of them. But then you find out with candid interaction that this person is actually looking up some very important information about a topic that you were just discussing, and they're actually helping you in your presentation. And isn't that nice of them? So now you know this with the help of candid interaction, which we show on this spectrum. So on the left, we have subtle interaction, which tries to keep interactions hidden, as I mentioned. On the far end of the spectrum, you have collaborative interaction. And collaborative software designers, for a long time, have put a lot of effort into making some visual awareness cues that explicitly make information available to others so that people know what you're doing within the workspace. So candid interaction fills this gap. We have our whistling user there who's relaxed, and he's happy to share his device activity and provide some awareness in some everyday social situations that are not necessarily collaborative. So to demonstrate this concept, I'm going to show the following short video.
Cool glasses, are they new?
Yeah, they're new smart glasses. Now I can keep up my social networks everywhere I go.
Cool, so guess what? The funniest thing happened. Are you paying attention to me? I can't tell.
Oh, no, sorry. I was looking at this new trend called Candid Interaction.
Okay, so you mean like candid camera?
No, Candid Interaction isn't about hidden cameras. It's about providing awareness to others about how we are using our devices. They cheese.
Hey, I can tell that you just snapped a photo.
That's right, Emily. I thought you might like Candid Interaction too, so I brought you this jewelry for sharing when you use your favorite apps.
Cool, now you can see when I'm checking Twitter.
Or goofing on playing games.
Thanks, guys. I think Candid Interaction is swell.
So to begin our work, we started with a survey where we we sent a survey out to 100 participants to Mechanical Turk to find out some information about how people perceive mobile and wearable devices and how they're currently using these and how they perceive activity on these type of devices. One thing that we learned is we verified that the perception is that wearables are more difficult to observe activity than other types of devices. And of course, there was a diversity of opinions For instance, a lot of participants would say something like, only when information is relevant, only then would I be willing to share my information. But there are also a lot of participants with the opposing view that would say something like, I would be willing to share my information in any situation. I think it's impolite not to mention what I'm doing if I'm around others using my devices. So we have this wide spectrum of users, but overall, about 84% of participants indicated that they would sometimes be willing to share information with others about their device activity. And of course, this varies by context. So for instance, people are more willing to share information with coworkers or with friends in a social situation than they are, they're more comfortable with that than sharing information about their device activity with strangers in public. So next we created a design space for Candid Interaction. I'm just going to share a few of the dimensions here, give some examples. So one is modality, and we tried to think of some different ways that you can convey feed through to observers. Another dimension is granularity. So the amount of information that you can show very fine-grained events, or you can show very coarse events. And then we also have representation. So information can be conveyed in a very abstract way, or it can be very explicit and precise. Next, we created a prototyping platform where we interconnected a number of devices, including a smartphone, a smartwatch, and a pair of smart glasses. So we want to cover a wide range of this design space. So we came up with many, many ideas, and we ended up implementing these 7 prototypes. And these range from some very practical implementations to some very whimsical designs that really try to push the boundaries of this design space. So the simplest of these is called grounding notifications. And these demonstrate some of the very elementary concepts of Candid Interaction. So to demonstrate these, I asked for some help from my friend Haijun, who's going to be acting as the device user. And I want you to imagine that you're having a conversation with Haijun, and you are the observer. So imagine you're out in the hallway after the talk, and you're having a conversation with Haijun, and he pulls out his phone, and he's like, what is he doing with his phone? And you may get a toast notification like this. It says, oh, Haijun has opened an application, and it tells you which application he's opened. So this is essentially what grounding notifications does. So grounding notifications is, in the design space, we talked about granularity. So these show only very high granularity events. You're not interested in low-level events. You just want to know, for instance, if he's opened a particular application, such as his email. Or in this case, Haijun has just opened a search link in his web browser, and now you are presented with this preview. So you have the option to click on the preview or the little button beside it, and now you get a little bit a bigger image of the preview that you can see what Haijun is doing. And if you so wish, you can tap that preview icon, and now that brings you to the web page, and you can now follow Haijun along as he does his surfing. So another element that we looked at in our designs is something called back channels. So now you're observing Haijun, but Haijun needs to have some information about what you're observing. So one method of conveying that is through some audio information. So for instance, Haijun, each time you receive a text notification, you might hear a sound like this. So Haijun now can hear that sound and realizes that you have just received a notification about his activity. Thanks, Haijun. Okay. So another element of this is a control panel. So of course, people are concerned about privacy of what they're sharing, and they also don't want to have too much information needlessly about what others are doing. So they'll be drowned in that information. So we implemented this feed-through filters control panel where people control both the amount of information that they're sharing and receiving using these sliders. The next prototype I'm going to share is called lock screen stripes. So this shares an abstract representation of an actor's usage history. So one of the design elements was abstract information, and this is the one design that shows some historical information as well. So when you place your device on the table, sorry, just back up. When the user places the device on the table, it detects that and displays this abstract representation. And now observers can see what applications you've been using, represented by the stripe thickness and color, and the order represents the time of usage. Next, we have semantic focus. This is designed using this acrylic knob attached to the back of a laptop, and this is analogous to the focus control on a typical camera. So the idea behind this prototype is imagine a world of ubiquitous projection, and you can use this focus control to control the amount of granularity of the information that you're sharing. So it's a very kind of intuitive way to control the information granularity. So imagine you're at a meeting and your projection is showing some information about your usage, for instance, what kind of application you're using, and you can use the focus knob to, if you want some privacy, you can blur out the application so people can see that there's some change there, but they won't necessarily see the icon of the app that you're using. Conversely, if the knob is turned all the way in the other direction, it shows this miniature overview of the detail of your application, and important changes appear up in the marquee so that they're more visible. The user can also dial back the semantic focus slightly to obfuscate this information if they come across some sensitive information. The next prototype is the status band, and this uses an abstract representation of light, and this uses the modality of light from our design space. So this can represent some different types of activity through distinct motions, for instance, opening an application, taking a photo, recording some video or audio, navigating between pages, and we have scrolling, and also fine granularity events such as entering text or crushing candies. Next prototype is iconic jewelry, and this uses these laser-cut acrylic pendants, and each item represents one of the user's favorite applications. So this is different from the other prototypes that it uses the modality of motion, and it does this using this shape memory muscle wire. So each item begins to move when the associated application is opened, and the item will continue to oscillate gently as long as there is activity within the application. Next, we have proxemic AR, which uses augmented reality to reveal a user's activity. So when the observer peers through the display of a smartphone, they see a virtual thought bubble above the user's head, representing which application is being used. In this case, the information granularity is controlled through proximity. So as the user moves closer, they see some additional activity within the application. For instance, each time the user sends a tweet on their Twitter account, the observer can hear this bird chirping. And now when the observer moves even closer into the user's personal space, you get some additional activity from the application is revealed, for instance, some hashtags. And this also works on when the observer is wearing this smart glasses device, and here we see the view through the smart glasses lens, and the observer can see the user crushing some candies, and the candies appear to be flying out of the user's ears as the score is updated on the marquee above. Okay, so finally we have the fog hat, and this uses a pico projector to show some application feed through on a screen of mist. This wearable prototype provides a physical version of this virtual thought cloud. So whereas the proxemic AR used proximity for implicit control, this gives the user explicit control using overgranularity, using the feed-through filters control panel. So they can show varying amounts of detail. For instance, they can share their search query in this application. However, if they're typing an email, the marquee is placed a little bit higher up in the turbulent region to limit the readability of the text. And also, if the user wants additional privacy, we added an onboard fan that the user can activate, and this creates some additional turbulence as well in the mist display. We had 5 groups of users come in for to gain some preliminary feedback. So we would get them to use the prototypes as much as possible, and we want to get some initial ideas about what they think. So as in the survey, these users were very generally receptive to the idea of sharing. Reinforced the idea that context is very important. For instance, people preferred the abstract representations. I really appreciate the option to have the earrings or the colored wristband if they go out in public, and people can have some information without necessarily having a lot of detail about what they're doing. And we found that backchannel is a complicated thing. So for instance, when people were looking through the smartphone display, they thought for an extended period of time, it felt a little bit strange to be viewing somebody through that display. So we need to look at some additional modalities for some feed-through and future work, or sorry, for backchannel and future work. We also want to develop some more further interactive features, some more robust context awareness features to deal with the complexities of social environmental contexts. And with these advanced prototypes, we'd really like to do some in situ testing to send these prototypes out into the wild and really dig into the complexities of this type of interaction. So we really hope that our detailed design space and this variety of prototypes will inspire some future research on candid interaction. Thank you.
We have time for a few questions.
Very funny talk. It was great and informative. I'm not trying to. So Dan Vogel, University of Waterloo. So one thing is that people lie. So I know that there used to be this trend with video games where you'd have a boss key and it would show like an Excel spreadsheet. So, you know, the boss would come by and you're like, oh, you're working good. How do you deal with this? Like, how do you build up the sense of trust? And would people just misuse a technology like this?
So trust is very important. So I think that actually this can help foster a sense of trust. So rather than relying only on subtlety, that actually sharing some information and having people do this voluntarily can actually help kind of grease the wheels of this social interaction. So of course, it is, as I mentioned, very complex. And so for instance, if people are sharing information now, maybe it introduces this feeling that, oh, now everybody has to share all the time. So I think there's a lot of room to dig into how to handle these social complexities, partly through intelligent interfaces that can detect these things, but also giving a lot more advanced features for people to control what they're sharing and they're receiving. And there's probably some room to mix candid interaction with subtle interaction and even deceptive interaction. And I think some future prototypes or future devices, deployments, may use a wide range of this entire spectrum and not just one individual piece. But this gives some additional options for designers to use.
I mean, it could even become more revealing when people aren't sharing, right? So if I choose not to share something, then it's actually revealing something else about what I'm really doing. So it's a really interesting space. Okay. Yeah, so, thank you. Yeah, you don't have to answer that.
Thanks.
Hi, Kent Lyons, Technicolor. So it's great that you're starting to kind of poke at this space. It's a space I've been thinking about for a long time, for obvious reasons. So I'm wondering how much you're seeing kind of with, I say, novelty effects, right? So wearables are very new. People have very poor mental models of what they are and what they're doing. Laptops, on the other hand, can be equally as private and equally as opaque with privacy screens and things like that. And so I'm wondering if you got any data or insights from your participants that might indicate if this is a transitory thing or kind of points in one direction or another. And I'd say kind of phones are somewhere in the middle there. Yeah, insight.
I think it's very, so yeah, we did intentionally include a laptop in our designs because we think this is relevant, and of course each of these devices is hidden to different degrees, but the laptop and even a mobile phone can exhibit some of these. We haven't dug as far as we would like to in future work into some of these insights. I think what we did find is that there is a variety of perceptions. So there are some users who are very timid about sharing, and their initial reaction is that this is crazy and they don't want to share anything at all. They think that there's no way, they just want to keep everything private, as was reflected in those survey quotes. But there are a lot of users that are extremely open to the idea. So I think the important takeaway is really to support this diversity of different user types and to provide options really, so it really has to be a voluntary thing. So this will not work if people are forced to share information. They have to opt into this, and it really has to support a wide variety of different users and different needs.
Hi, Santiago Alfaro, Intel Labs, and thanks for the talk. Have you thought about, now that you mentioned how people can be timid, to actually aggregate the data instead of having individual data points? So for example, in a context like this, could you have, I don't know, the lamp turn blue the more people are checking Twitter, or red the more people that are doing something else?
Mm-hmm. Absolutely. I think that you're right. So one thing we're looking at with the projector is that maybe this feed-through can be incorporated into the environment. So instead of necessarily being attached to the user, the feed-through could appear on the observer's device, and this is actually an element in a design space. So it could appear on the user's body or device. It could appear on the user or the user or the observer, or it could be in the environment. So any of those elements or some combination of them.